Welcome back to lesson 20 where we are going to study the limit comparison test. So giving a series, we compare the series that they give us, like one of these 10 problems, we compare with someone that we know that converge or diverge. And the comparison test will tell us that the series, if the series converge or diverge. So how exactly it will work? This this test. The test will work like this. If V sub n converge and if A sub n, if the series that converge is here, let's say that the series that converge is the V sub n, this one is the one that converge, and this series is greater than A sub n, or A sub n is smaller than the series that converge, then these converge. So if you know that this one converge, and you find another series that is smaller than the one that converge, for sure this one converge. So in this test, we assume, let me erase here, minus. We assume that we know, for example, that 1 divided by n squared, the series 1 divided by n squared, converge. So because it converge, you can compare with another series. For example, let's go to compare to invent some series. I know that the series 1 divided by n squared converge. These converge. Let's go to find another series that is smaller than this one that converge. For example, the series summation from n equal 1 to infinity of 1 divided by n plus 1 square. Is this series term by term smaller than the one that can convert? Well, I know that n plus 1 is bigger than n for sure because I'm adding to n the number 1. So 1 divided by n plus 1 is smaller than 1 divided by n. So 1 divided by n plus 1 square is smaller than 1 divided by n squared. So this series converge. So the other one converge. This series also converge. And now how about a series that diverge? For example, imagine that you know that the series summation of 1 divided by n, you know by the integral test that summation from 1 divided by n diverge. So this series diverge. So you use this like your thermometer to measure if another series diverge. How you will do it? If the series summation divided by 1n diverge, and there is another series V sub n that is greater than the one that diverge, so the summation of these diverge, and this is your thermometer. You measure here, and the one that you want to test if is diverge, if this is bigger than the one that diverge, this will diverge also. So the setup is to put correctly the two things different. If you are looking for convergence, the series that you will use as thermometer is this one, the one that is in this side. And you are looking to thermometer, and you are looking to test if this series A sub n will converge. If it's happened that the a sub n is smaller than one that you know that converge, like 1 divided by n squared or 1 divided by n cubed, so this one will converge. For divergence, the rules are different. If you know that, for example, this is your thermometer, 1 divided by n, you know that these ones diverge. If you find another series that is greater than the one that diverge, then these diverge. So this is explained here, and this is the theorem. Let's go to apply the theorem now to the problems. Well, the other thing that is related with what I have said is the limit comparison test. The limit comparison test, it says if you have two series which every term of the series are positive, a sub n and b sub n is positive, and you do the limit of the first divided by the second, and this limit is a finite number, different than 0 and positive, and not infinity, it's a finite number. So the two series goes one hand by hand. So if these converge, these converge. If these diverge, these diverge. The idea is that the limit of both of them, of the a sub n divided by b sub n, have to be L, and L have to be finite. Either both converge or both diverge if the limit is finite. We will use this test in problems to solve problems. First problem is say use the comparison test to determine the divergence of convergence of the test. So I will say like this, 3, I will say, let me look for my thermometer. My series that is a thermometer is this one. And this one I know that converge. So if I can prove that this series 1 divided by 3n squared plus 2 is smaller than 1 divided by n squared, I will say these converge. And this one is smaller than my thermometer series that converge. Then my thermometer series, then it will converge. Then it will converge. Now, let's go to prove that this is true. 3n squared plus 2 for sure is bigger than 3n squared. And 3n squared for sure is bigger than n squared. Okay, so I have 3n squared plus 2 bigger than n squared. So 1 divided by 3n squared plus 2 is smaller than 1 divided by n squared. Remember that if I do the inverse, if I flip here, I have to flip also the inequality sign. So what happened now? So these converge. These one converge. Why? Because the integral test say that these converge. So this one is smaller than the one that converge. Then it will converge. And now is already proved the convergence of this series. So what it say here, the series converge by the comparison to the convergence series 1 divided by n squared. You can compare with this one. You don't need the 3. Okay. To the next one. Use the comparison test. You see, I see here 1 divided by n. If I can prove that this one is bigger than the one that diverge, this one diverge. So 5n 5n minus 3 for sure is smaller than 5n, because I'm subtracting to 5n 3, so this should be smaller than 5n. 5n for sure is smaller than n, smaller than n. Well, no, it's not true. It's not true. 5n is not smaller. For example, if n is 5, 5n is 25, 25 is not smaller than 5. So this is not true. So, but what is true is that 1 divided by 5n minus 3 is bigger than 1 divided by 5n. But 1 divided by 5n is 1/5 of 1n. Okay, so what happened here? This series here diverge. Why? Because the integral test or the P series say that when n equal 1, the series diverge. Now, this series is greater than one that diverge. So because it's greater than the one that diverge, this series diverge. And the problem is done. Of course, if 1 divided by n diverge, 1/5 of 1 divided by n also diverge. So let's go to the next problem. Let's go to solve this problem, problem 3. Use the direct comparison test to determine if the series natural log of n divided by n plus 1 converge or diverge. Which series will you use to compare with this series? I will use the series 1 divided by n plus 1. 1 divided by n, the series 1 divided by n diverge. And of course that the series 1 divided by n plus 1 also diverge. So I will compare with this series that diverge. So if I can prove that the natural log of n divided by n plus 1 is greater than one that diverge, if this I know is my thermometer, if this diverge, because this is greater, this one is greater than the one that diverge, this one will diverge. So I can prove that this one is greater than this one. Yes, of course that I can prove, because natural log of n is greater than 1, and is the same numerator. So because natural log of x of n, because natural log of n is greater than 1 after some n, when n goes to infinity, natural log of n is infinity, so it's bigger than 1. So I have proved that this one, this series, the summation here and the summation here, so this summation will diverge. So this summation that is greater than the one that diverge will diverge for sure. Diverge. So the problem is done. Let's go to the problem. The next problems use the comparison, the limit comparison test. The limit comparison test is another comparison test that say like this. You take A sub n, the series A sub n, and let's say that B sub n is the thermometer, is the series that is a thermometer. You know what the V sub n is. You know that is convergent or you know that is divergent. And you compare with the A sub n, but now the comparison is different. It's not if one is smaller than the other one. The comparison is like this. You do the limit when n goes to infinity of A sub n divided by V sub n. If this limit is a finite number, meaning that is not infinity. If this number is a finite number, and v sub n is convergent, because v sub n is your thermometer, you know that it's convergent, then a sub n is convergent if this is a finite number. Now, if this is also a finite number, and v sub n, the series that is your thermometer, diverge, and a sub n divided by v sub n, the limit when n goes to infinity, is a finite number, then a sub n will also diverge. What it says the limit comparison test is that the structure of v sub n converge or diverge is the same structure of a sub n converge or diverge. They go hand by hand. If v sub n converge, a sub n converge if this is a finite number. Okay, let's go to apply what I have said to this series. The series is n divided by n squared plus 1. So the series is n divided by n squared plus 1. So this is a sub n, let's say. And let's go to do the limit when n goes to infinity of a sub n divided by n squared plus 1. Divide by v sub n. What is your thermometer series? I see here the n and I see here the n squared. I see 1 divided by n. So I will put the thermometer 1 divided by n. My series thermometer will be 1 divided by n. And I will see if this limit is a finite number. If this is a finite number, it will mean that because these diverge, this one will diverge. Okay, let's go to do this limit. So this limit is the limit when n goes to infinity of n divided by n squared plus 1 divided by 1 divided by n of n divided by 1. So it's the limit when n goes to infinity of n squared divided by n squared plus 1 is equal to the limit when n goes to infinity. I will divide numerator and denominator by n squared, and this limit will be equal 1 divided by 1 plus 0. 1 divided by 1 is 1. Because 1 is a finite number, the limit is a finite, so the structure, the v sub n was divergent, so this series diverge. Wow. Now let's go to do problems 5. It says use the limit comparison test, so a sub n divided by b sub n, to determine the convergence of the divergence of the series. The series is 1 divided by n squared multiplied by n plus 3. This looks like n cubed, so I will try to test, because I know that 1 divided by n cubed converge because of the p series, because the p, 1 divided by n to the p, if p is greater than 1, converge. So I will try to look for the limit when n goes to infinity of this 1 divided by n cubed, divided by the other one. The other one is 1 divided by n cubed plus 3n. It's the same if you put it the first divided by the second. It's exactly the same here. The idea is that the limit have to be finite. And here the idea is that you know that these series converge. If the limit is finite, it's because this one converge the other one. So let's go if this series converge. Okay, we do the limits. So doing the limits, it will be the limit when n goes to infinity of 1 divided by n cubed multiplied by n cubed plus 3n divided by 1. This limit is the limit when n tends to infinity of n cubed plus 3n divide by n cubed. So I will divide numerator and denominator by n cubed. So if I divide numerator and denominator by n cubed, this limit will be 1 plus 0, because this will tend to 0, because it's 1 divided by n squared. When n goes to infinity, 1 divided by n squared goes to 0, divided by 1. So the limit is 1, and the limit is a finite number. It's not infinity, it's not 0 also. It has to be between 0 and infinity. So because the limit is finite, the nature, they go hand by hand. So this is convergent, the limit is finite, this one is convergent. So the series is convergent. Okay, let's go to the next. And the next problem is do the same thing. Use the limit comparison to determine the convergence or divergence of this series. Which series do you think that you will use? I see 4 to the n, that is a geometric series that converge. So I will divide this series by 1 divided by 4 to the n. Okay, so let's go to do it. Is the limit when n goes to infinity of the series is, let's go to do it anyway. Let's go to do it. The series is 1 divided by 4 to the n. Remember that 1 divided 4 to the n is the series 1 4 plus 1 4 square plus 1 4 cube, etc. So this is the series whose r is 1 4. Because the r is less than 1, this is a geometric series that converge. So if this converge and this limit goes finite, the series that I will put here, that I'm trying to know if it converge, will be convergent. So the convergence of the series is hand by hand. If this converge, because I know it converge because it's a geometric series, and the limit is finite, this one will converge. But we don't know if the limit is finite. So we need to do the limit. So the limit when n goes to infinity of 1 divided by 4 to the n multiplied by 4 to the n plus 1 divided by 5. What is this limit? This limit can be solved by dividing numerator and denominator by 4 to the n. If we divide numerator and denominator by 4 to the n, we have, when n goes to infinity, 1 divided by 4 to the n, this will go to 0. And this will be 5 by 4 to the n divided by 4 to the n. This will be equal, this limit will be equal to 1 plus 0 divided by 5 times 1. This is 1/5. So the limit is 1/5, and because the limit is finite, it means that the series converge. The series that I put here will do the same thing that the series that I put in the numerator. It will also converge. I'm sorry that I did the limit differently here, but it's the same thing. Okay, it's the same thing. Don't pay attention because I divide this one divided by this other one. It's the same thing, no problem. Let's go to the next problem. The next problem says, determine the convergence or divergence of this series. Well, I will see if the a sub n goes to 0. If they don't go to 0, the divergence tests say that the series will diverge. So what is a sub n? A sub n is 2n divided by 3n minus 1. Oh, and what is the limit when n goes to infinity? With the limit when n goes to infinity of 2n divided by 3n minus 1 It's been done by dividing by n, numerator and denominator. So this will tends to 2, this will tend to 3, and the other one will tends to 0. So it will be 2/3. So if the a sub n doesn't go to 0, the series diverge. So this series diverge. Let's go to the next one. Determine the convergence of the series tangent 1 divided by n. Let's go to write the secret. Is tangent 1 divided by 1 plus tangent 1 divided by 2 plus tangent 1 divided by 3. 1 watt, 1 radiant, of course, plus tangent 1 divided by 4, etc., etc., etc. So you sum, you see here what you are summing. You are summing tangent of x is to it like this. In pi divided by 4 is an asymptote. Okay, pi radians divided by 2, pi divided by 2, that it is the asymptote is 3.14 divided by 2. It's like 1.7. This is 1.7. So the 1 is here. So it's tangent of 1, this one, plus tangent of 1/2, this one, this eighth, plus tangent of 1/3. Okay, this is 1/3 is something here, 1/3. Plus tangent, it will convert the sum. You see that the last term will go to 0, so the divergence test will not tell me that this diverge. So who will tell me that this diverge? Oh, the comparison test. The comparison limit test will tell me if this diverges. I know, you see the divergence test will not tell me that it diverges, because this is a condition to well, because it will not tell me. So what I will choose, because it's appear here tangent of 1 divided by n. I know that the series 1 divided by n is the harmonic series, and this series diverge. So I will try to do the limits when n goes to infinity of tangent of 1 divided by n divided by 1 divided by n. If this limit is a finite number, these diverge, and this one will diverge if the limit is final. If the limit is not 0 or not infinity, the nature, they will go hand by hand. If this diverge, this diverge. So to do this limit tangent of 1 divided by n, to do these limits, we maybe do L'Hopital rule, because when n goes to infinity, 1 divided by n goes to 0, tangent of 0 goes to 0, and when n goes to infinity, 1 divided by n goes to 0. So this is of the form 0 divided by 0. This limit that we have to do is of the form 0 divided by 0. So it will apply L'Hopital rule. So we limit when n goes to infinity of tangent of 1 divided by n divided by 1 divided by n is equal to the limit when n goes to infinity of the derivative of the numerator. The derivative of the numerator is the derivative of tangent of x. Tangent of x is secant square of x, secant square of 1 divided by n, secant square of 1 divided by n, by the derivative respect to the n of 1 divided by n, which is minus 1 divided by n squared, divide by the derivative of the denominator. The derivative of the denominator is minus 1 divided by n squared. So now these two will cancel, these two will cancel, It will be the limit when n goes to infinity of secant square of 1 divided by n. When n goes to, or the limit when n goes to infinity of 1 divided by cosine square of 1 divided by n. When n goes to infinity, 1 divided by n goes to 0. Cosine of 0 is 1, so this limit is 1. So because this limit is 1 and is a finite number, the thermometer, the series 1 divided by n diverge, so this one diverge. It means that the sum of all this height that I have done, all this height, you see, all of this one, this plus this plus this plus this plus many more that I can put it here, 1 divide 1 half, 1/3, 1/4, the sum will diverge. Oh, interesting. So another problem, and the next problem is determine the convergence or divergence of this series 2 to the n plus 1, 5 to the n plus 1, and I see here 2, 5 to the n. And I see a geometric series with r 2/5. So I see a convergent series. 2/5 is less than 1, is the r. So I will compare this series with the series with the geometric series 2, 5 to the n. So I will do the limit when n goes to infinity of 2/5 to the n divided by 2 to the n plus 1 divided by 5 to the n, 2 to the n, 2 to the n, 5 to the n plus 1. So this is the limit of a sub n divided by v sub n, the limit when n goes to infinity. When n goes to infinity. If this limit is a finite number, the series, this one that is a convergent series, because it's a geometric series, if this limit is finite, this will mean that the other series is also converge. It's also convergent as the series in the numerator. So let's go to do these limits and see if the limit is 2/5 of 2 to the n divided by 5 to the n multiplied by 5 to the n plus 1 divided by 2 to the n minus 1. So how I will do this limit? How I will do this limit? So it will be equal to the limit when n goes to infinity of 2/5 to the n, 2 to the n divided by 5 to the n. And now this fraction I'm going to divide everything by 2 to the n divided by 2 to the n. So I divide the numerator by 2 to the n, and I divide the denominator by 2 to the n, and I have not done anything. Dividing the numerator and the denominator by the same thing, it will not be any change. So this will go to 1. This, when n goes to infinity, 2 to the infinity goes to infinity, 1 divided by the infinity goes to 0. So this will be 1 minus 0. So 1 minus 0. This 5 to the n divided by 2 to the n multiplied by 2 to the n divided by 5 to the n will be 1. 1 plus 2 to the n, so there is a parenthesis here, okay, plus 2 to the n divided by 5 to the n multiplied by 2 to the n. So this 2 to the n will cancel, and I will leave 1 plus 1 divided by 5 to the n divided by 1. What is the limit when n goes to infinity of this? This will go to 0. When n goes to infinity, 5 to the n goes to infinity, 1 divided by infinity goes to 0, so the limit is 1. So because the limit is a finite limit, it means that this one is convergent, so the other one is convergent because the limit is 1. That's all. Let's go to this one. Determine the convergence or divergence of this series. You see here, if you see here, there is an n squared, here there is an n to the 5. So I see here the 1 divided by n cubed. N squared divided by n5 is 1 divided by n cubed. So I will test this with this series. This series converges. So I will test the limit when n goes to infinity of 1 divided by n cubed divided by 2n squared minus 1. So I'm dividing a sub n divided by v sub n. A sub n is this one, a sub n is this one, and b sub n I take it like this one, and I'm going to see the limit when n goes to infinity if it's going to a fixed to a number, a limit number, 2n squared divided by 3 n fifth plus 2n plus 1. And this limit is the limit when n goes to infinity of what? 1 divided by n cubed multiplied by 3n5 plus 2n plus 1 divided by 2n squared minus 1. Okay, so what I will do, I will divide everything by n cubed. Let's go to do it. Limit when n goes to infinity, so I will divide numerator and denominator by n cubed. So it will appear, if I divide 3 and 5 by n cubed, it will appear 3n squared plus 2 times n divided by n cubed will be n2 divided by n squared plus 1 divided by n cubed. Divide. If I divide here by, this is 2 and 5, it will be 2 times and 5 divided by n cubed, it will be n squared, minus 1 n cubed divided by n cubed minus 1. Okay, when n goes to infinity, this goes to 0. This goes to 0. I will divide again by n squared. Limit when n goes to infinity, 3n squared divided by n squared. 2n squared divided by n squared minus 1 divided by n squared. Okay, this will go to 0 as n goes to infinity. Okay, this goes to 0, this goes to 3, and this goes to 2, so the limit is 3/2. So the limit is a finite number, so because it's a finite number, it means this one converge, yes, by the 1 divided by n cubed converge p, the p is bigger than 1, is 3. So 1 divided by n cubed converge. So because these converge and the limit is a finite number, this one converge. And the problem is solved, and this is the last one. Okay, I'll see you in the next lesson.